Video on combinations. Today I'm going to be working through just a few examples of how you do combinations and using the formula to calculate them. This is a part of the combinations and permutations unit for Algebra 2, and this video is made to kind of just get you started if you're running into any problems. Alright, a combination is a collection of objects where the order in which they are chosen doesn't matter. So it doesn't matter which order you choose a set of things from a given pool of objects. Some popular examples are selection of people for a committee without positions, because if I said like president, vice president, treasurer, etc., now it matters what order I choose them in. And choosing 10 books out of 15 to take on a trip. It doesn't matter what order I choose the books in, it just matters that I choose them. Alright, so let's get into a simple example. So, a formula first. So if we let n be the total number of objects, k be the number of objects selected, then we use this formula here. And just to be clear about what that formula actually is, it's not friendly to the eye, but what we're looking at here is this factorial sign. Okay, and this is what kind of freaks kids out. If I had something like 5 factorial, what that means is that's 5 times 4, let me straighten out my tablet here, times 3 times 2 times 1. So basically just like I take all the descending integers, I multiply these together, and what I would end up with here is 120. So 5 factorial is equal to 120. Alright, so here's a simple example. So I've got 11 actors, and they're trying out for a play. Only 6 of them are going to be getting a callback. So how many ways can the callbacks be done? Well, if I go back to the original formula, my n here is 11, and my k is 6. Okay, because there are 11 actors, and I'm choosing 6 of them. Alright, so the order I choose them in, it does not matter. So I'm going to go ahead and use my combinations formula. Whoops. Alright, so that should be a 6, not k. Alright, so I start with 11 factorial. I divide that by k factorial, which is 6 factorial. And then 11 minus 6, the factorial of that. So that comes out to 11 factorial divided by 6 factorial. And then 11 minus 6, when we use order of operations here, I come out with 5 factorial. Alright, so now what I'm going to go ahead and do is actually write out this whole calculation. So in the numerator I've got 11, 10, 9, and I'm just going to go ahead and go all the way down, and you'll notice a pattern pretty quickly into doing these problems, but at the start I think it would probably be the best if you actually wrote out all of this just to get started. And then 6 factorial, 5, 4, 3, 2, 1, and then 5 factorial, so now I do a string 5 factorial. Okay. So now what I'm going to go ahead and do is cancel out all of the obvious stuff instead of doing all these multiplications. Well, I see a 6 here and a 6 up here. There's a 5 up here, 5 down here, and I'm just going to go ahead and cancel out all of this. And then the 1s don't really do anything anyway, so I'll just go ahead and get rid of all the 1s. Alright, so now what I'm going to do here is I'm going to get rid of this 5. And if I get rid of this 5 in the denominator, this 10, there's a 5 up here in this 10, so that's now going to become a 2. So now I'm going to get rid of the 5, and I'm going to change the 10 into a 2. I'm going to go ahead and get rid of this 4, which makes this 8 change into a 2 up here. I'm going to get rid of this 3, which is going to turn this 9 into a 3. And I'm going to get rid of this 2, which is going to get rid of this 2. And so now basically what I have here is 11 times 2 times 3 times 7. And now I'm just going to go ahead and calculate this. I have a calculator off to the side here. And I get 462. There are 462 ways I can do these callbacks. And that does not really seem terribly obvious when you first kind of like think about it. But I can understand the notion that it's not intuitive directly. So, I mean, you're just going to have to practice with it at first. Alright, so this is a simple example. The trick here is really just taking your time with the calculations. Alright, now this is a harder example. So, what I've got here is this ultimate coach, and I'm choosing a starting lineup with 4 defensive players and 3 offensive players. If there are 8 players on defense and 6 players on offense, how many lineups can be made? Well, this one is not super obvious because there's 2 different things I'm choosing here. First, let's talk about defensive players. So what I've got here, there are 4 defensive players that are on this lineup. And what's going to happen here is I'm choosing those from 8. Alright, so let's think about this if we think about the total things we're actually doing here. Alright, I'm choosing a lineup of 7 people. So I've got 7 of them. And what I'm saying is there are 4 of them which are going to be defense. So here are my defense players. Well, those 4 were chosen from this pool of 8. So really what happened was I said, all right, let's take these 4 folks here and we'll put them in my lineup. Whereas in the case of the other thing I was choosing from, I had 3 offensive players and there were 6 that I was choosing from. So what happened was I had 6 offensive players and I chose these 3, and I'm just choosing these at random. And they go here. Alright, now what we basically have here is I have 6 offensive players and I'm choosing 3 of them. So I could choose these 3, I could choose any other 3. So I've got 6C3, but then on the other hand, back with the defense, I have 8C4. So what has to happen here is I have to calculate 2 separate things. And then what I'm going to end up having to do here is multiplying this at the end. And that's going to be my answer, because this is the number of ways I can choose this thing, okay, this set of options. This is the number of ways I can choose this set of options. So we would need to kind of go from there. Alright, let me go ahead. Alright, I'm definitely going to need more space for this. Alright, so let's start with the defense. With the defense, I had 8 players, and I was choosing 4 of them. It doesn't matter what order I select them in. So what I would have here is 8 factorial over 4 factorial times 4 factorial, and that would be 8, 7, 6, 5, 4, 3, 2, 1, divided by 4, 3, 2, 1. That's the first one, and then the second 4. Alright, I'm just not even going to worry about the ones. Truthfully, I don't even know why I bothered writing them. Alright, I'm going to cancel this 4, this 4, this 3, this 3, this 2, this 2. Now I got 8, 7, 6, 5. Well, what I'm going to go ahead and do is say, alright, 3 times 2 is 6, so I'll cancel out the 6 here. And the 4 goes away, which makes this a 2. So now what I end up with is 2 times 7 times 5 is 70. Alright, so that's the number of ways I choose my defensive players. Now, I'm going to choose my offensive players. I have 6 of them, and I'm choosing 3. So now I've got 6 factorial over 3 factorial, 3 factorial. And I end up with 6, 5, 4, 3, 2, 1, and 3, 2, 1, 3, 2, 1. I'll get rid of the ones. And I'm just going to go ahead and make life a little bit easier for me here. I see this 3 and 2 is going to make 6, so I can cancel out this 6. If I cancel the big numbers, it does make life easier. And now I'll get rid of this 3 and this 3, and this 2 and this 2. And so what I'm left with is 5 times 4, which is 20. And now what I'm going to go ahead and do to get my solution, I'm going to multiply these together. 70 times 20 is 1400. Alright, so 1400 is my answer here, and that's how we go about solving these problems. And this is a hard example. I mean, there's some where you'll have to do 3 and 4 different calculations and then multiply them together. Really, all you did was 2 easy problems and multiply the answer together. The hard part here is thinking about when you're actually doing a combination. Alright, the tricky part of some of the basic problems is figuring out when you're using either combinations or permutations. What a lot of kids do is they think it's a combination when it's a permutation, and it's a permutation when the order matters. And the second thing that you typically see here, the formula can get complicated, but it's really straightforward when you take your time in the calculations. Alright, I hope this helps.